Disclaimer for this session. Now let's talk about the session agenda. We will talk about why write asynchronous code. We will take a brief look into the task-based asynchronous pattern, or TAP for short. We will delve into the new asynchronous programming features of SnapDevelop. And we'll also look into the new .NET DataStore and SnapObjects asynchronous APIs. Following, you may find more information about myself. I've been in the industry for 20 years now, and I have been working with Power Builder for the last 15 plus years or so. There are some few recent projects and some social media links right here as well. Following, you may find some more information about Appeon. Okay, let's now jump in directly into the first key question. Why write asynchronous code? Well, for starters, it enables your application to handle more users. Most multi-user applications, such as websites, use a thread for each user session. There are a lot of threads in the thread pool, but if a lot of users try to access the site, then the threads can run out, which in turn leads to blocking code. Also, there is a memory cost for each thread that has started. So if you have requests that access an external resource such as a database or a web API, then asynchronous programming frees up the thread while it is waiting. This means you will use fewer threads and thus avoid reaching the maximum number of threads too quickly. Plus, it enables you to use less memory as well. You can process multiple input-output bound methods in parallel. So if, for example, you needed to access several remote services, either in legacy systems or over the web, and then combine the results to display them to the end user, if this were done synchronously, then the process would take the sum of the access times for each service. With the new async await feature, you can easily run them all in parallel, and then it takes only as long as the longest access time. You can make your interface more responsive to the end user. If you have a request on a site that is slow, and you can make the site more responsive by starting the action synchronously and returning to the user before the action has finished. There are some issues around handling errors if the synchronous task fails, but for places where your application interfaces to an external system that is slow, this can be worth the effort. You can also take full advantage of your server resources. Asynchronous request handling with async and await can help your application scale. However, this is scaling on a single server. You may still need to plan to scale out. If you do need a scale out architecture, you'll still need to consider stateless, independent request, and reliable queuing. Async and await do help somewhat, but they enable you to take full advantage of your server resources, so you won't have to scale out as often. But if you do need to scale out, well, you'll need a proper distributed architecture. Plus, this handles more server requests by yielding threads to handle more requests while waiting for input-output requests to return. It enables UIs to be more responsive by yielding threads to UI interaction while waiting for input-output requests and by transitioning long-running work to other CPU cores. So simply put, asynchronous programming is the execution of code independent of the main program flow and how to deal with such execution. The execution of asynchronous code happens concurrently with the main program flow. Now, asynchronous programming is heavily used nowadays because of the high demand of concurrent computer processes and the need to evolve the computational power of today's world. Let's now talk about the task-based asynchronous pattern, or TAP. It is based on the system threading task and system threading task result types and the system threading task namespace, which are used to represent arbitrary asynchronous operations. TAP is the recommended asynchronous design pattern for new development. Writing input, output, and CPU-bound asynchronous code is straightforward using the .NET Task-Based async model. The model is exposed by the task and task T types and the async and await keywords in C#. So let's look into a code example of what this means. You can immediately notice that this is a public C# method. It is marked as asynchronous because of the async reserved word at the beginning of the method's declaration. It also is returning a task of type string. The methods and properties of the task T object enable callers to monitor the progress of the task, which will complete when the code in this method has executed. Next, we will find the name of the method, getFirstCharactersCount async, along with two parameters, a string for the URL and an integer for the count. Then we will create a new HTTP client object, somewhat similar to PowerBuilder's HTTP client. Execution of the method is yielded to the caller on the next command. GetStringAsync returns a task of type string, which is actually awaited. Execution then resumes when the client getStringAsync task completes, becoming synchronous again. And this is an example of an asynchronous input-output bound operation. But what does that mean for this server scenario? Well, this model works well with a typical server scenario workload because there are no threads dedicated to blocking on unfinished tasks. The server thread pool can service a much higher volume of web requests. Consider two servers. One that runs async code and one that does not. For the purpose of this example, each server only has 5 threads available to service requests. Note that these numbers are imaginarily small and serve only in a demonstrative context. Now let's assume both servers receive 6 concurrent requests. Each request performs an input-output operation. The server without async code has to queue up the 6th request until one of the 5 threads have finished the input-output bound work and they have written a response. At the point that the 20th request comes in, the server might start to slow down because the queue is getting too long. Then the server with async code running on it still queues up the 6th request, but because it uses async and await, each of its threads are freed up when the input-output bound work starts, rather than when it finishes. By the time the 20th request comes in, the queue for incoming requests will be far smaller, if it has anything in it at all, and the server won't slow down. Although this is a contrived example, it works in a very similar fashion in the real world. In fact, you can expect the server to be able to handle an order of magnitude more requests using async and await than if it were dedicating a thread for each request it receives. What does this mean for client scenarios? So the biggest gain for using async and await for a client app is an increase in responsiveness. Although you can make an app responsive by swapping threads manually, the act of spawning a thread is an expensive operation relative to just using async and await, especially for something like a mobile game. Impacting the UI thread as little as possible where input-output is concerned is crucial. So more importantly, because input-output bound work spends virtually no time on the CPU, dedicating an entire CPU thread to perform barely any useful work would be a poor use of resources. Additionally, dispatching work to the UI thread, such as updating a UI, is very simple with async methods and does not require extra work, such as calling a thread-safe delegate. Now, CPU-based async code is a bit different than input-output bound async code because the work is done on the CPU. There's no way to get around dedicating a thread to the computation. The use of async and await provides you with a clean way to interact with the background thread and to keep the caller of the async method responsive. Async and await are the best practice for managing CPU-bound work when you need responsiveness. So in this code example, the task.run method queues up the work in the thread pool, as you can see right here on the second line of code. Note that at this point you can do some other work concurrently. For example, as calculate result is still executing, so you can do any other processing. And then execution of the calculate result is yielded at the await event method. Okay, so this takes us to our next question. Why do we provide asynchronous related features? Well, for starters, the most important APIs in our runtime for both SnapObjects and .NET DataStore are meant to interact with the database. And these APIs are input-output bound methods. Previously, only the synchronous methods were provided. Asynchronous programming can improve the scalability of server performance and summarize the utilization of server resources. Asynchronous programming is widely used in the Web API web development nowadays, and keeping up with the top-notch industry standards is a good practice. And that's why we provide encapsulated asynchronous methods that can help users to write asynchronous code more thoroughly and elegantly. Let's now talk about the new asynchronous programming features in SnapDevelop. For the runtime, SnapObjects and .NET DataStore, all asynchronous APIs, are implemented internally using asynchronous code for database input-output bound operations. And we'll take a closer look into that in the demo. For SnapDevelop, we have incorporated new features that can support coding and debugging asynchronous methods more conveniently directly into the IDE. We also provide a solution that integrates Runtime and IDE in order to support writing asynchronous methods more easily. So, in more general terms, we can categorize the new features in two different ways: Runtime Enhancements and then IDE Enhancements. Now, for the Runtime Enhancements, we have added new asynchronous programming methods for all database-related web APIs or APIs. So everything that it has to do with database methods, for example, the retrieval method, the update method, or the save changes method from the SnapObjects SQLModelMapper method. All of this APIs that have to do some work on the database, and they have all been enhanced. Now for the IDE enhancements, we have incorporated new templates for scaffolding services and controllers that include the new asynchronous methods. But of course, you can create your own template too. Now the Web API Tester tool has also supports now testing asynchronous method calls. Well, this actually makes it very convenient for me to, go ahead and develop, run, and then again debug my source code, and everything in the same IDE. I don't actually be having to change from one IDE to the next and so forth. You can also debug your asynchronous code to write in the IDE and also inside of the Web API Tester tool. Okay, so let's go ahead and take a look at the first enhancements, which are the runtime enhancements. Okay, here we have SnapDevelop open. So here is where I would actually show you the new features of SnapObjects and .NET DataStore, which include the asynchronous programming features. So first of all, I would like to point out the fact that my project is now targeting .NET Core 3.1, as you can see right here. And this is a very nice thing because .NET Core 3.1 is the latest .NET Core release from Microsoft. And not only that, this is a long-term support version. So this is also supported by SnapDevelop right now. So that's good, right? So now that we have seen this .NET Core support, I can continue on and carry on with my demo code. So first of all, let's talk a little bit again about the task-based asynchronous pattern, or TAP. Now remember that I told you and I mentioned before that we have two types of operations: CPU bound operations, and then we have input output bound operations, as you can see right here. So I can actually do the TAP, or task-based asynchronous pattern programming, right here with any one of them. So for that, I would require the task right here, as you can see. And what this is going to be doing for the CPU based operation, it's actually going to be queuing up the work on a thread pool right here. So this is the task run. It's going to be running this expensive calculation method right here. And the nice thing about this is that even though it is doing that, it's actually going to be running. You can actually do some more other work concurrently. For example, adding some other methods, some other calculations or something. For example, as calculate result is still executing right here. So then once that all this processing finishes, then it would be yielding the execution of the calculate result method right here, waiting or awaiting for this to actually finish up taking its process. So this is the CPU based operation, and then we have the other one, which is the input output based operation. Now you will notice some differences right away. One of them is the fact that we would be doing an await and async directly into this. We're not going to be using the task.run method. Instead, we have the async. We're returning a task. In this case, it's going to be a string. This is my method name. I'm going to be accepting two parameters right here. I'll be doing some synchronous work right here. And then, as you can see right here, it says execution of get first characters count async is yielded to the caller right here. So get string async returns a task which is awaited. So we are awaiting this get string async method right here. Once the execution resumes with the client get string async task completes, and then here it becomes synchronous again. So this is just an example of the TAP, the task-based asynchronous pattern programming. Now let's look into the details of the APIs from the .NET Data Store. So first of all, and only for comparison reasons, what we're going to be doing is we will be taking a look first at the example of a synchronous method. Once again, this is synchronous. So I'll open this up. This is my service, which is my D department service, and you'll notice right away that I have a data store, and I would be performing a retrieval and update operations in this methods right here. So this is a traditional synchronous method call right here, as you can see. So this is how we supported it in previous releases of SnapDevelop. Now let's take a look at how we could be able to perform input-output bound operations in this other demo code. So I'm opening up again another service, and in this service again I have a task, which is what I would be returning of this data store type. I am accepting a parameter, which is this department ID, and I am also accepting a cancellation token. Now this is doing the input-output bound operation right here, and it is doing the retrieve method, which is commonly used, the retrieve, which is synchronous. But in this code, this thread is started separately in task run. And it is actually not blocking the calling thread, as the .NET DataStore retrieve method is still synchronous. Before the database returning the result set, this thread continues to wait for the database to return. Therefore, it cannot achieve the purpose of releasing the thread back to the thread pool. So this kind of code cannot achieve complete asynchronous programming techniques. Now let's look into the new one, the real asynchronous methods for input-output bound operations. So you'll notice immediately right here in this method that we are accepting, well, this is actually a suffix that is actually called the async, and we have in it the task that will be returned. It is returning the .NET Data Store, and I am accepting the parameter type, which is decimal, and it is department ID, and I'm also accepting the cancellation tokens. Now in this .NET Data Store, I'm awaiting the retrieve async method call, and as you can see, I'm actually passing in the department ID and the cancellation token. So this is actually the one that's handling more server requests by yielding threads to handle more and more requests, while we are actually waiting for the input output request to return. So that's a nice thing. Now some of the benefits of this recommended asynchronous methods is that the kind of asynchronous code is simplified, and it's actually easier to write and maintain. And because the retrieve async method of the .NET Data Store is provided by us, it actually implements asynchronous methods internally too. So the await keyword can also release the thread back to the thread pool in time. And once again, this is increasing server scalability. But it's not the only method we provide. So let me just click right here and let's go to the definition of this. You'll notice that every input-output based or bound operations are actually also available in an asynchronous way. So for example, I have the retrieve async right here, and reselect row async, for example. We have many others. Let's look, for example, at the update async method right here. So that is also available. Now this is talking about .NET Data Store, but you may also wonder, what about SnapObjects? Is there any asynchronous capabilities in that? Well, good news, it's also supported. So let me just close all this up, and let's go see some examples of asynchronous programming inside of .NET Data Store. Well, we already saw .NET Data Store, but let's take a look at SQLModelMapper. So here in this service I have right here, we have .NET Data Store with an asynchronous call, and here we have the SQLModelMapper. So again, this is accepting the async keyword right here, and it's going to be returning a task of this specific D department. And again, we're accepting cancellation tokens. Now this SQLModelMapper is loading asynchronously, as you can see right here, and is actually going to be awaiting the call. So let's look into some other supported new methods from this SQLModelMapper. So you'll notice again that any other input-outbound operations are also supported asynchronously. So for example, load all async, and let's look a little bit down. So we have a saves changes async, and supporting the cancellation tokens too, and so forth. So that's good news. We also have supported asynchronous programming for .NET DataStore and for SQLModelMapper. But what about SQL Executor, another SnapObjects object? So in this case, let's see that we have this SQL Executor. Again, it's an async method right here, and we will be awaiting the select async process to complete. And again, it's once again we have, for example, the select lazy method also supported, select lazy async method right here, and so forth. So that's a very nice thing about it. Okay, so let's go back to our PowerPoint. Okay, so far we have seen the new APIs for asynchronous programming both in .NET DataStore and SnapObjects. But it's time to look at the new enhancements for the IDE that will provide better support for asynchronous programming. And once again, these are the new scaffolding templates that support asynchronous methods. Now, I know that you may think that this is not a big deal, but in fact it actually is, because it provides everything I need to get my web APIs created. I can start creating web APIs with no hassle, and since I already support both synchronous and asynchronous programming, I can actually create my methods for both programming techniques directly within my project. It's also a good practice to separate everything that is asynchronous in a specific asynchronous object. For example, if I have a web API, all my methods that are asynchronous, it's always a good idea to place them in one single web API project. And then I can also create a different web API project specifically set for synchronous methods. So this is always a good idea, and it's one of the recommended ways that you can approach this. But of course, it depends on your personal development styles and needs. So then the next thing that we will be talking about is the Web API Tester tool and how it can run asynchronous methods too. But not only that, you can also run your test, and you can also debug your test directly from within the Web API Tester tool. Now, once again, the Web API Tester tool is a very fancy tool because it actually helps me save a lot of time. And I'll show you in just a second, but just to let you know, this Web API Tester tool, if you haven't used it, I strongly recommend it. I in fact love it a lot because it's one of those things that makes me test my code very easily without having to open up a third-party tool and then set it up, and or creating a front end for my test, or having to open up a web browser, then remembering the websites and the URL addresses and parameters and all that. So we'll take a look into this Web API Tester tool and this demo too. Now we can also debug asynchronous methods in SnapDevelop. Now there are two ways to actually get to do that. You can do that directly from within the IDE, or as I said before, you can debug your test with the Web API Tester tool, which is also a nice thing because you can be running your tests and debugging, so that way you can set up your parameters, your values, anything that you might need to actually get it running. Or perhaps you want to debug a really complex data window and send it to the Web API, and then you can directly catch it. So that way you don't have to be mingling around with complex JSON and all that. And the Web API Tester tool provides this this functionalities, but you can directly, debug your test directly without the Web API Tester tool. Just debug, run and debug. So let's look at this new features in SnapDevelop now. Now we can take a look into the new features of the IDE. So let's go ahead and take a look at the first one, which is the new scaffolding templates that support asynchronous methods. So as you can see right here, once again, I have this .NET DataStore, which is based on a .NET on a data window right here. Now, what I'm going to be doing is I would actually scaffold this as services and controllers based of this .NET DataStore. So again, this is focusing on this .NET DataStore, and you'll see that we have new templates right here. But more specifically, these templates now support synchronous programming and asynchronous programming. So it's basically the same. And once again, you can also create your own templates if you wanted to. And you can also set the parsing rules too right here. It's up to you. But right now, we'll just leave it as is. So what I'm going to be doing is I would be scaffolding this. I don't need a base class right here, so I can just remove that. And again, I'm targeting my project right here. I'm also selecting the subfolder this is going to be inside of, the namespace, the data context. I can also create a new data context if I want. I also have a template for my controller right here. Again, this is the project and the subfolder and so forth. So I can also set up the specific methods I want to use for this controller. So I'll just leave it as is right now. But then again, I would like to mark the fact that these are specific asynchronous methods. Of course, I could just leave it as is, but I want to, name it very fancy so that I can actually have this set up to my right here. So here we go, customer async service, and then we have the customer async controller. Now what I'm going to be doing is actually generating this services and controllers. I'm going to be saving the changes. So here we go, and there we go. This actually created the async service right here for me. And again, you can see that this is already placing the data context into my constructor method right here. And right here we have the main method for my specific API. And remember that this is a CRUD functionality. So what this is actually doing for me is a CRUD template. It's actually creating the retrieval and the update of my specific .NET DataStore. So in here, it actually created again the async prefix right here with its task and the await, and it's actually going to be retrieving asynchronously for me right here. So this is the service, and right here is the controller. Basically the same thing, async, task, and await. In this case, it's going to be returning it directly right there. I also can set up the cancellation token right here. So this is my service. Let's look into the controller now. Okay, so here is my controller, and again, if we scroll down, you will notice that my controller is actually going to be doing an asynchronous call. It is returning a task, and it would be awaiting the services retrieve asynchronous method to complete. So this is actually going to be yielding right here for this to actually finish running. Then it would be returning whatever I need. So this takes me to the next new feature. This is the Web API Tester tool that it can actually run asynchronous methods too. So let's go ahead and take a look, make sure that everything's going to be running. So first of all, I need to see that my controller name is customer async. Then I need to make sure that everything's set up in the startup. Let's see, it seems that I'm Okay, I just have another because I was doing another example right here, so I just comment that out, save the changes, and there we go. So then this means that I'm actually going to be able to run my my test. So back to the controller right here, and we're on the retrieve asynchronous method again of the controller. So if I now right click inside of this method, I will get this new menu, and in the menu I can find the run test option right here. If I click on it and wait a second for it to actually load, this is actually popping or bringing up the Web API tester tool. This again, this is a very nice tool because I don't have to create a front end for my test to run. I don't have to mingle around complicated JSON, and it's actually going to be doing very nice things for me, saving me a lot of time. And let's see why. For example, right here I have my list of controllers, right? I also have a list of methods that I have run before. But right here I have my controller, so I have the customer asynchronous controller, and I also have a sample controller. But I'm not gonna worry too much about this one because this is just a sample. So this and customer async, I have two methods in this controller. I have the retrieve and update. So let's go take a look at the retrieve. As you can see, it's a get method right here, an HTTP call right here. And this is my Web API URL. I can set up any parameters if I wanted to, but I don't have any specific parameters for this. It's not looking for any, so I can also set up headers. It brings me the default ones, but I can also create new headers if I wanted to. For example, I can accept compression like so, right? Or I can add whichever one I want. It also handles authorization, so I can also manage basic authorization, JWT tokens, or OAuth 2.0, etc. And I can also manage cookies right here. But let's just go ahead and run this asynchronous method. So there you go. It's actually running asynchronously. So it returned, it finished up everything. It brought me a total count of 130 rows. It is returning a status 200, which means it is okay. This is the time it took for it to retrieve. Of course, since it's the first time, we just don't count that first time because, you know, it's catching everything up for me for the first time. So then what I need to take a look into here is the headers, the return headers. As you can see, it also supports the return headers, general data from it as well, request headers and all that. And it's also accepting cookies for me right in here. And going back to the body, I can see this as a pretty right here, or raw data, and so forth, right? So this is the Web API tester tool. It's actually supporting asynchronous methods right here. So now let's go ahead and take a look at the next step right here, which is actually going to be the one for debugging my asynchronous method calls. So I can actually close this. Now, of course, I can actually debug this ones right here, but I have a better one already prepared for you. And let me get that open so I can show you this method that I want to actually debug for you. So let's take a little look at the source code of it. So as you'll notice, I have right here a synchronous method, which is again a retrieval of this customer. But I made some little changes right here. So what this is going to be doing is actually going to be doing an await for the retrieval, asynchronous retrieval of this data store. It's going to be awaiting it. And once it finishes, it would actually check if it actually returns something. If it did, and then it's going to be telling me how many rows it retrieved. So let's see what this actually will do once I run the debugger for me. So I'll run it right here. And let's give it a second for it to build and do all the necessary magic behind the scenes. So I'm going to scroll this a little bit up so that we can have enough space. Scroll this right in here and go back to here. So okay, now my asynchronous method is already, well, my web API is running. I need to call the asynchronous method, so let's go ahead and do that. Now right here I need to put the name of the controller, which is the customer async, remember? And then my retrieval method. Now this is going to be retrieve, and I'll just click on enter. Now what this is actually doing, it's already retrieving. It hit the breakpoint right here that you see right here, so it's going to be awaiting for this response. Let's take, so this is the thread number right here, and as you can see, this already changed the thread, so that means that this is actually running asynchronously as we expected it to. So then again, these are the new features of SnapDevelop IDE and how it is now integrating and supporting this asynchronous programming features directly into the IDE. Okay, so that concludes this session. But if any one of you guys or anybody would like to leave some more comments, you can do now on the comment section. And I would also let you know that I would like to include this references to all the topics that we covered in this session in the comment section. So if you would like to learn more about asynchronous programming in C#, you can refer to all this right here. Of course, there's more to get around from, but I'm providing everything that I used for this session. Okay, so please remember that you can connect with the Appeon community. You can join us at community.appeon.com. You can see discussions, tech articles, videos, free online training, and more. Of course, there are MVPs actively answering the community site, and there is also Appeon staff actively looking into the community website. So of course, you can get a lot of feedback from current Power Builder developers and get a lot of questions answered, and some code exchanges and such. So you can also find our social media links right here. Okay, thank you very much for joining us at this Elevate session. Have a good day.